Hello everyone. In this ell101 project, I will be discussing the practical use of diode through a real life example of light emitting diodes. So the topics covered in the presentation would be theoretical explanation of diodes and diode circuits, some basic current analysis containing diodes, and then first some brief explanation about LED and different application devices using diodes. So what is basically a diode? It is a two-terminal device which allows the flows of current only in one direction, as for the other direction ideally the resistance is infinite. It is made up of semiconductors and is a crystalline piece of semiconductor material with a PN junction connected to two electrical terminals. About LED, LED stands for light emitting diode, is a device that emits light when current flows through it. LEDs are nothing but are diodes which are heavily doped PN junctions, and as we all know that excitations occurs in the semiconductor from the valence band to the conduction band, and when the de-excitation occurs, the energy is released either in the form of heat or in the form of photons. And if the photon that is coming out lies in the visible range, its wavelength lies in the visible range, then we see light of different colors depending on the energy levels, energy gaps between the conduction and the valence band. An LED is encapsulated with a transparent cover so that the emitted light can come out. This is the circuit representation of an LED, where this representation is of a typical diode, and these arrows represent the light which comes out through the diode due to the current flow. So, as the working principle is already discussed, when the diode is forward biased, the minority electrons are sent from the P to N junction, while the minority from the N to P, and the excess minority carriers at the junction recombine with the majority carriers, and the energy released in the form of photons lies in the visible range. So, we see the emitted light. This is the pictorial representation of the working principle of LED, and this is a typical circuit where RS is the external resistance, Vs is the source voltage, and this is a symbol of an LED uh, with the voltage Vf across it, and this is the formula for RS, which can be easily found out using the KVL equation. And in this pictorial representation, we can see how the recombination of electrons produces a photon, light photon, uh, uh, light photon in the LED. So, what determines the color of an light? The color of light depends on the energy required for the electrons to cross the band gap of the semiconductor, and the two primarily used materials in LEDs are aluminium gallium indium phosphide alloys and aluminium gallium nitride alloys, and the slight changes in composition of these alloys changes the color of LED light, and the voltage drop or the voltage gap is shown in this table. So these are the several benefits of using LED over the conventional light sources, like it is highly efficient, environmentally safe, UV free, highly effective, around 20 to 50% less heated, uh, similar similar percentage for reaction time, longer span, low maintenance, has a high color variety, smaller in size for different multiple size and shapes, highly durable. So these are some benefits of LED over the compact fluorescent and incandescent bulbs. Diodes are widely used in many of the real life applications, for of which some are rectifiers, Zener diodes used as voltage regulators in operational amplifiers and transistors, and diodes are the basis of performing millions of digital logic gates and in demodulation effect to remove the negative signals from the AC current, and also to create power supplies. These are the pictures showing rectifiers, Zener diodes, transistors. These all contains diodes primarily, And in this logic circuit, it is also a diode circuit. And in this signal demodulation, in this circuit we can see the the use of diode here. Rectifier is nothing but a combination of diodes based on whether it is full wave or half wave rectifier. Thank you. Myself Part Soni from Energy Science Department, Group 18.